we begin with the F block elements now. In the F block elements, you will see, first we have to say what is the position of the F block elements in the modern periodic table. The position is just below the modern periodic table, below the entire D block, the P block and the S block comes the F block. The F block is indicated here in purple color. As you can see, it consists of the 4F and the 5F series, and it is also called the 5D and the 6D transition series. What are the elements in the F block? In the F block, you can see the elements have atomic numbers 58 to 71, which are called the lanthanides, and the elements from atomic number 90 to 103, which are called the actinides. See here, 58 is cerium and it goes on to 71, that is lutetium, 90 is thorium and 103 is lawrencium. So from where did we begin? We began from group 3, where you see scandium, yttrium, lanthanum and actinium. After lanthanum comes cerium. Then the F orbitals start to fill. They completely fill till 14 electrons. So you see 14 elements over here till lutetium, atomic number 71. Similarly, for actinides, we have got, it begins from after actinium, that is 89 is atomic number of actinium. We start from thorium 90 atomic number to lawrencium 103. Again, if you count, there are exactly 14 elements. That means the F orbitals are in the process of being filled from number 1 electron to 14 electron. We will see to the peculiarities of this electronic configuration soon. Now, the periods and the groups of the F block elements. The F block elements are in group 3 of the modern periodic table. The periods are 6 and 7 and they are placed at the bottom of the modern periodic table. The characteristic features of the F block elements, you can see here, is that they are having two series. The F block elements consist of two series. The upper series of elements is called the lanthanides. The lower series of elements is called the actinides. In each series, there are 14 elements. You can see here that some of the atomic numbers are white. We can't see them, right? 61 for example. That is promethium. Again 93, neptunium. Now 93 onwards till lawrencium 103. Now these are highly radioactive. Promethium has a very short life and it is not available in nature as such. It is made in the labs. So now these elements from neptunium to lawrencium and further, they are called the transuranic elements. They come after uranium. Next, we see that it is very interesting to note that the F block elements are the only blocks where there are 3 incomplete outer shells. Now, what do we mean by this? The F shell, okay? Then not the F shell, the F orbital, that is you are having the 4F or the 4th orbital, the 5th orbital and the 6th orbital. All of them are not completely full. See, the 4F is in the process of getting filled. 5D has only 1 or 2 electrons or may not have any electron at all. And the 6th orbital has only S orbital. The 6th orbit has only S orbital filled, that is 2 electrons. What about the 6p? What about the 5f? Here in the lanthanides you can see the 5f remains incomplete. The 6p remains not at all complete and the 4f is in the process of getting filled. So the 4th, 5th and the 6th orbits are incomplete orbits. Next, the lanthanide series starts from cerium, atomic number 58. The 4f orbitals keep filling gradually with the 5d orbitals having no electron except at gadolinium and lutetium. These are having half filled and completely filled f orbitals. The actinides form the second series of the F block elements, and this series begins with the element thorium, atomic number 90, involves the elements up till atomic number 103, that is lawrencium, or by IUPAC name we call it as un-nil tri-um. The general electronic configuration of the actinides is, this is radon 5F 1 to 14, inner core electron is of radon. Then we have 5F 1 to 14 electrons, 6D 0 to 1, 7S2. This is for actinides. For the lanthanides, the inner core electron corresponds to xenon 4F 1 to 14, 5D 0 to 1 and 6S2. Now, the actinides are unique in the sense they involve the transuranic elements. These elements have atomic number greater than 92, that is come after uranium, and all of them are radioactive. From neptunium to lawrencium in the F block, and after lawrencium they go on into the P block. The remaining transuranic elements appear in the P block. All these elements were discovered in 4 different laboratories, in Berkeley in USA, in Russia, in Germany and in Japan.